Okay, so this is section 5.3, and this is a follow-up to the investigation that we did today with the geometer sketch pad. And this is going to talk about angle bisectors of a triangle. So the angle bisector, basically this is going to be, in this particular case, ray AD is going to come through, and it's going to split this big angle BAC into two congruent angles. So that's why you see the little arc marks here. That's because that guy is congruent to that guy. Now, if you pick any point that's on this angle bisector and drop a perpendicular, you're going to know that those two things are going to be congruent. So like here, BD and DC, since they both come straight down perpendicular to the side of the angle, they're going to be congruent. But again, remember how we define that distance. It's from the point straight down. So BD is also going to be congruent to DC. So the converse of the angle bisector theorem, here's what this says, how this is a little different. This says, hey, I'm wondering, is this ray right here, does this bisect the big angle BAC? Well, if you take a look at it, if you look at this point that's on this ray, this guy right here is the same length, BD is the same length as CD. So if this length here, again, this has to be perpendicular, straight down, straight down. If those two lengths are the same, D has to be on the angle bisector. So the theorem from back here says you know you have the angle bisector, therefore any point has to be equidistant. The converse says this: you have points that are equidistant, therefore this must be an angle bisector. So using this, we'll take a look here. It says find the measure of the angle CBE. Well, we know that this BE right here has to be an angle bisector. And how we know that is because if we take a look at the lengths of CE and DE, they're the same. So if this again is straight down perpendicular, and the two segments are congruent, you know that E has to be on this angle bisector. So if this is 31, this has to be 31. So the incenter, again, this is what we talked about today with the geometer sketch pad, but you have the point of concurrency. Remember, that's where they all intersect. The point of concurrency where all three angle bisectors of a triangle is going to be called the incenter. Remember, concurrency means intersect. And this is basically what it's going to look like. So again, we did this today. We constructed this point P, and then basically here's what's happening. This guy right here comes through, bisects the angle. This comes through, bisects the angle, comes through, bisects the angle, hits at P. If you drop a perpendicular, boom, DP, and then if you also do it here, boom, PE and PF, these three are going to be congruent. They're going to be equidistant from that incenter. You don't know anything else right now. You don't know that BP is congruent. You don't know PA is congruent. PC, you don't know that at all. This guy you also don't know right here. You have no idea if DA is congruent to DB. That was what we did with the circumcenter. But this right here does not necessarily split that opposite side here into two equal pieces. So here they're telling us that L is the incenter. So right away you can say, well, if L is the incenter, I know GL, IL, and KL all have to be the same length. What they're asking us to do here is to find LK. So remember, if LK is the same as GL, well, I could use the Pythagorean theorem. If this is a right angle, then the other side also has to be a right angle. So I could use the Pythagorean theorem, and that could tell me what the length of GL is. If I know GL, then I can say, well, GL is the same as KL. And that's basically what this is saying right here. And actually, when I look at this, the information that we have here, we're actually going to find IL. Now that I look at that, we're going to find IL here. Although it is true that we could, if we knew GL, it would be the same. The information that we're given here helps us to find IL. It does not help us to find GL. So we can use the Pythagorean theorem right here. We can go a squared plus b squared equals c squared. And that's going to help us to figure that out. Once we know IL, then we're going to know KL, or LK. So here they have it set up, a squared plus b squared equals c squared. And again, we've got Li, we don't know. IH is like the b, it's going to be 12 squared. And the hypotenuse here, which is like HL, c squared, that's going to be 15 squared. So if we square this, square that, 225, subtract 225, take away 144, we're going to have L squared is equal to 81. To get that by itself, what we're going to have to do is take the square root. And that's going to give us Li. And again, because we know Li is the same as Lk, Lk has to be 9. So a couple of things right here. Again, I know that this is an angle bisector because this distance is the same as that. So that angle, that little sliver right there, has to be the same as the other one. So I know that 3x minus 5 has to be the same as 2x minus 5, that guy and that guy. If we solve it, we get x is equal to 10. And then here, we know that we have an angle bisector because of those right there. If this is an angle bisector and these are perpendicular, I know that 7x plus 3 has to be equal to 8x, and then I can solve for the x. Then going on to this one right here, if you take a look, do we have enough information to conclude that AC is an angle bisector? No, we don't. We do not here, because although that is congruent to that, we don't know that when CB comes down, it's perpendicular. If this was a right angle and that was a right angle, then we would have enough information. But just simply saying that the two things are congruent is not enough to say that it's on that angle bisector. So that's pretty much what this is saying right here. And this will be our last problem. And if we take a look at this, this is the one from before. They're just changing this up a little bit, and they are just saying that suppose you weren't given HL or HI, and you were given different things instead. You were given that JL here is 25 and JL is 20. And if we wanted to find LK, well, it's really the same as that problem before, in the sense that because you're given that this L is an in-center, you know Li is going to be the same as LK. So if you find Li, you're going to be able to find LK. So the way that we're going to set this up is we're going to take a squared plus b squared equals c squared, or Li squared plus ij squared equals Lj squared, and just substitute in. They tell us that ij or ji is 20. They tell us that jl or Lj is 25 squared, and we want to find this. So 625 minus 400, square root that to get plain old Li, and Li is going to be 15. And since Lk equals Li, Li is also 15. And that's all we have for the notes.